Hello everybody. Today I am going to discuss about basics of electromechanical systems, where we will see the relationship between flux and current, then how this flux and current relationship can be useful for development of electrical machines like transformer, DC motor, DC generator, AC machines, etc. Some of the basic electrical laws like Kirchhoff's current law, Kirchhoff's voltage law, then magnetic laws like Ampere's law, Faraday's law of electromagnetic induction, Biot-Savart's law, etc. can be used to explain these circuits. So let's start. Before starting those things, let's discuss a little bit history of this electromechanical system. Initially, the industrial revolution gained momentum from steam age. The various advantages of machines and gadgets encourages researchers to find new sources of energy. Still, nowadays also new sources of energy we are searching. At the end of 18th century, invention of storage batteries received great attention. In 1820, it was discovered that electrical currents are associated with magnetic field. So this can be assumed as a invention of electromagnet. That means by applying electrical current, magnetic field can be developed. In the year 1821, it was found that if a current carrying conductor is placed in a magnetic field, it will experience a force. This can be assumed as birth of a motor. A better explanation of relation between electrical and magnetic field was proposed by Faraday in the year 1831, and he has given few very popular laws, and these are still popular as Faraday's laws of electromagnetic induction. About 3 decades, the research on DC motors and generators proceeded in parallel path, and with the invention of commutator in the second half of 19th century, it was discovered the same machine can be used as motor as well as generator. These inventions generated great interest in the generation of electrical energy. Other useful machines like alternators, transformers, and induction motors came into existence almost at the same time, contemporarily. The evolution of these machines was very quick, and these machines attained their physical configurations and applications quickly. Even these machines are popular today. Electrical machines basics. Basically, two types of machines are there: electromagnetic machines and electrostatic machines. In electromagnetic machines, we can categorize as motors, generators, transformers, and in electrostatic machines, these are electrostatic generators or Van de Graaff generators, you can say. But we will focus more on motor, generator, and transformer as these machines are more popular for electrical drives. Basic working principles of electromagnetic machines like motors, generators, transformers are similar. They are based on following laws: electrical circuit laws, Kirchhoff's current law, Kirchhoff's voltage laws, then magnetic circuit law, Ampere's law, Faraday's laws of electromagnetic induction, then Biot-Savart's law. We will focus more on third and fourth laws to explain working of motor, generator, and transformers. The law of electromagnetic induction, Faraday's law, states that if the magnetic flux lines linking a closed electrical coil changes, then an EMF is induced in the coil. This EMF is proportional to the rate of change of flux linkages and mathematically can be expressed as E proportional to d psi dt. Psi is flux linkage or flux linked with the coil. Psi can be expressed as phi into number of turns of the coil. Phi is flux lines in Weber. So psi is equal to Weber turns phi into n. So the equation 1 can be represented as E proportional to n d phi dt. Now As per Lenge's law, the direction of the induced EMF will be such that it will produce an effect to oppose this change in flux linkage. It is analogous to the inertia in the mechanical systems. The changes in the flux linkages can be attained in the following three ways. First one, changing the magnitude of the flux linking a static coil. That means the coil is stationary and the flux is changing. Second is coil is moving but flux is stationary. Third one, both coil as well as flux are varying in nature. The first one is the basics of transformer. In a single phase transformer, we know that two windings are there, primary winding and secondary winding. Across the primary winding, we are giving the AC supply. That AC supply produces current of varying in nature. Because of that current, flux is varying. And the flux is varying, that flux gives you the primary winding of the transformer and EMF is induced. And the same flux linked with the secondary winding of the transformer, then EMF is induced. Second one is moving the turn outside the region of steady field. This is nothing but working of motor or generator. Third one is moving the turn and changing the flux simultaneously. This is your analogous to induction machine. This is a block diagram of electromechanical system. Here you can see that electrical system and mechanical system. In between this one, you can see this is your electrical system. This is your mechanical system. In between this one, this is a magnetic system. That means if we are giving electrical energy as input, that electrical energy is converted into magnetic energy, and then magnetic energy is converted into mechanical energy. And in case of generator, we have to give mechanical input or the mechanical energy as the input, and that mechanical energy is converted to magnetic energy, then magnetic to electrical output we are getting. So for motor, this is electrical, then magnetic, then mechanical, and for generator, mechanical, magnetic, electrical. And the electrical systems are nothing but just voltages and current. Magnetic energy, it is related to flux, and the mechanical system, it is position, speed and acceleration of the rotor. This magnetic flux, here the similar thing is there. Here the same thing is represented, that voltage and current. Here Kirchhoff's current and voltage law will be applicable to model the system. Here in case of motor, this electrical energy is converted to magnetic energy, and the magnetic energy will create a force or torque, and that force and torque can be expressed using Newton's law. And in case of generator, reverse will happen. Here a mechanical system will be represented in terms of force and torque, and those force or torque will produce induced EMF, and ultimately Kirchhoff's current and voltage law will be applied to obtain the generated output voltage or power. So today we have just discussed basics of electromechanical system, and we have seen that there are three ways to obtain induced EMF across the coil. First, by keeping the coil stationary and changing the magnetic field. Second, moving the coil keeping magnetic field is stationary. And third one is moving both magnetic field or variable magnetic field as well as moving the coil. And these three systems or ways to obtain induced EMF will be the basics of transformer, motor, generator and induction machine. So based on these basics, we will explain in later classes working of motor, generator and transformers. Thank you.